Hello everybody. In this video we will discuss and we'll derive the Henderson Hasselbalch equations. So let's say we have an acid, weak acid HA, which is in equilibrium with its acidic proton H plus and its conjugate base. So this is our acid and this is our conjugate base. They are in equilibrium with each others. So for this particular reactions, what would be the equilibrium constant will look like? The equilibrium constant we know is basically concentration of product divided by concentration of reactant. Okay, so in this particular case, so what are our products? So our products are H plus ion. So we gotta find out the concentration of H plus ions. And what else we have in our product? We have also our conjugate base A minus and divided by our reactant. So in this case, our reactant is HA, the acid itself. All right. So for this particular case, if you look at here, this reaction is basically a dissociation of an acid, where an acid is dissociated into H plus and its conjugate base. So this is called, the equilibrium constant is also called acid dissociation constant, which is basically the same thing, okay? And this is written as Ka, acid dissociation constant, or dissociation constant of an acid. So basically Ka is H plus times A minus by HA. So I'm going to rewrite this. Ka is equals to concentration of products, H plus and A minus, divided by concentration of acid. So that's the equilibrium constant for acid dissociations. All right. So what if we take a logarithm on both sides? Take the log on both sides. Take the log of both sides. So if we take the logarithm of both sides, what will we get? So we'll get log of Ka equals to log of H plus times A minus divided by HA concentrations. So at this point, I would like you to remind couple of log formulas. So just a quick recap. So if you have log of A times B and you opens up the bracket, it becomes log of A plus log of B. All right. So on the opposite side, if you are dividing something in a logarithm and then you opens up the bracket, then it becomes log of A minus log of B. So every time you have something in denominator, that becomes negative. So keep that in mind. So now let's apply the same formula that we just did here. This formula over here is, what if this whole thing is multiplication of H plus with this? So let me highlight this. So what if this thing is multiplication of H plus with this thing here? So what if we open it up? So it's going to be log of H plus concentrations plus log of A minus times, sorry, not times, divided by HA. So we just opens it up. We just open it up to separate them out. Okay, so it becomes log of Ka. So at this point, I will rearrange the equation slightly. What I'm going to do is I'm going to move this one from right side to the left side. And when we do that, the sign changes. So before it was plus, on the left side, it will become negative. Log of H plus ions. Okay, and the same thing will happen. I'll bring this term from left side to right side. And when we do that, the sign changes as well. So it was positive before, now it would become negative. So it's become negative log of Ka, and nothing changes. Log of, oh no, I did a mistake here. Oh no, actually I did not do any mistakes. Glad. Okay, A minus by H A. Okay, so here's few things. When we have negative log, so negative log is replaced by P. P stands for negative log. So that's pretty much what we're gonna do here. So instead of calling it negative log, we're gonna call it P. Instead of people calling it H+, it just stands for pH. So pH is basically means negative log of hydrogen ion concentrations. Okay, and what's again negative log would be pKa. That's it, pKa plus log of A minus by HA. Okay, so that's the definition of Henderson Hasselbalch equations. pH equals to pKa. All right. So now we will apply a few things here. So when the pH, so you can look at this couple of ways. So let's figure out what happens when concentration of A minus. So I'm gonna rewrite this again. pH equals to pKa plus log of A minus is our conjugate base concentrations divided by acid concentrations. So what happens when concentration, so when concentration of conjugate base is equals to concentration of acid? Let's apply that scenario. So what happened in this particular case? So if these two are equal, so let's say these are 5. So that means 5 divided by 5 is what? 1, right? So this means they will cancel out. pH equals to pKa plus log of 1, because if both of these terms are equal, then it's becomes 1. And we know that log of 1 is 0. So our conclusion becomes pH is equals to pKa. Okay, I keep pKa. Oh, P should be small case. So you notice here few definitions. So what is the definition of pKa? pKa is the pH when concentration of conjugate base equals to the acid. So I'm gonna rewrite this here. pKa is the pH of the solutions at which concentration of conjugate base is equals to the concentration of acid. That's the definition of your pKa. Okay, let's stop this video here and we'll do a problems in the next video.